Science, Grade 10, Turning Effects of Forces, Unit 11. Now look at this picture. You can see two rockets. If you start burning these rockets, one rocket will rotate to one direction, the other rocket will rotate to the other direction. So this picture shows the turning effect of forces. Right, now in this lesson we are going to discuss 11.1 moment and 11.2 the couple of forces. What are they? We have seen that by applying forces on an object, it is possible to push. If you apply a force on an object, you can push or pull or lift the object. Similarly, it is possible to rotate. Except pushing, pulling, lifting, you can rotate objects by applying forces on them. That is, by applying a force, we can rotate or turn an object around a given point. In this lesson, we will focus our attention on the ability of a force to rotate an object around a given point. First example. Now you can see a picture of a door. Here the door rotates around an axis passing through the hinges. This axis is known as the axis of rotation. So you can apply forces from these points marked on this from A, from B and from the place where this arrow is shown. At these points you can apply forces on the door. I think it will be clear to you that the force required to rotate the door decreases. It is easy for you to rotate the door when the perpendicular distance. Now this is the perpendicular distance to the line of action. This is the line of action of the force from the rotation axis is increased. If you increase this distance, it is easy for you to rotate the door. So it would also be clear to you from your experiences that the force required to rotate the door increases when the perpendicular distance to the line of action of the force from the rotation axis is decreased. If this length is low, it is very difficult to rotate. It is easy for you to rotate the turbine if you increase this length. Understood? So it is clear from this activity that the force, now this is the force required to rotate an object around this axis, depends on the perpendicular distance. Now this is the perpendicular distance to the force from the axis. Now this is the force, this is the perpendicular distance. So then what is moment? Before explaining it, now look at this picture. You can see the axis of rotation. Perpendicular distance is marked as R or D. We can use these letters. And the force. This is the top view of the door. What is moment? The product. The product of the force and the perpendicular distance to the line of action. Now this is the perpendicular distance to the line of action of the force from the axis of rotation is known as the moment of the force around this axis. Now you can see moment equals the force and the perpendicular distance. Force and the perpendicular distance. This is the moment of force. Let's move to the next slide. Now you can see a picture of a bar balanced on a support by keeping two weights. So this bar is balanced. Now we are going to remove one weight. First we will remove the left side weight. Then what will happen to the bar? Then it will rotate to this direction, clockwise. Again you have to keep the weight here and try to remove this weight, right side weight, then the bar will rotate anti-clockwise. So again you can see rotation. What is it? It's rotation. Now this is the axis of rotation, that is called pivot. Pivot, axis of rotation. This is the pivot. Right now, the anti-clockwise moment. Now this is the anti-clockwise moment. That means the distance from here to here and the force. The product of the distance and the force, that is clockwise moment. And anti-clockwise moment, how do you calculate? The perpendicular distance and the weight. The anti-clockwise moment acts downward on the left anti-clockwise moment, and the clockwise moment acts downwards on the right. Now this is clockwise moment and this is anti-clockwise moment. Now you can see a picture of a spanner or a nut key. Now you can see the turning effect produced by a force. Now this is the pivot. The nut acts as the pivot. The force applied is shown here and the spanner will rotate to this direction, clockwise. Clockwise. Right, now look at this picture. Again, a bar is balanced on a support and 4 weights are hung. Now this bar is also balanced. If you remove one of these left hand side weights, the bar will rotate clockwise, and again you have to hang that weight and try to remove one weight from this side. So if you remove one weight from this side, the bar will rotate anti-clockwise. Now in this picture, the bar is balanced. How many forces are applied on the bar? Now you can see 1, 2, 3, 4 weights are hung and the pivot is shown here. Pivot is shown here. Pivot, 4 weights are hung. So this bar is in a balanced position. If you remove one of these weights, you can rotate this bar clockwise or anti-clockwise. Now we'll move to next slide. How do you calculate? As I explained earlier, calculate the moment of a force. The size of the moment of a force can be calculated using the equation. Moment of a force equals force into perpendicular distance from the pivot. As I explained, we can use the letter D. Moment equals F into D. Force is measured in newtons. Distance D is measured in meters. So, the moment is measured in Newton meters. Capital N, capital N, simple M, Newton meters. Now, I have given you an example how to calculate moment. Now, look at this picture. Again, there is a bar which is balanced on a support. The pivot is shown here. 20 Newton is applied and another force is hung here. A weight is hung here, but the amount is not given. The perpendicular distances are given 12 meters from the pivot and here 8 meters from the pivot. So how do you calculate? First, we will take clockwise moment. If the bar is balanced, then the clockwise moment is equal to the anti-clockwise moment. 8 meters into F, clockwise moment, anti-clockwise moment, 12 meters into 20. So 12 times 20 equals 240 Newton meters and you have to divide by 8. The answer is 30 Newton. So the force applied here is 30 Newton. it's easy for you to do the calculations. This is an easy lesson. Another example is given here. Again, a bar is balanced on a pivot. The weight is 10 Newton. Perpendicular distance is 2 meters. Right side, the weight is 20 Newton. Perpendicular distance is 1 meter. Now, the clockwise moment, 20 times 1, 20 Newton meters. 2 times 10, anti-clockwise moment, 20 Newton meters. The anti-clockwise moment acts as downward on the left, and the clockwise moment acts downwards on the right. So, these two are equal. Clockwise moment is equal to the anti-clockwise moment, means the bar is balanced. Now, another example is shown here where the rotation is taken place. Raising a weight, a rock using a crowbar, and the pivot is shown here. This person is applying a force perpendicular to the plank. Now another example is shown here, a wheelbarrow. Here also the rotation occurs. And if we take the seesaw, is also another example for turning effect. These two are examples for rotation or turning effect of forces. Now you can see two examples here. Two examples are shown here. Turning effect of couple. We are going to discuss about couple of forces later in the next part of the lesson. Two forces are applied. Two equal forces are applied on the steering wheel. Then the steering wheel rotates, and you can see the bicycle pedal also. This one also rotates. Two examples for turning effects. The turning effect of a force is known as the moment, as I mentioned earlier. It is the product of the force multiplied by the perpendicular distance from the line of action of the force to the pivot or point where the object will turn. Pivot is the place where the object is turned. If moment equals F into D. Turning forces are found in many everyday situations and are essential for machines to function. Levers and gears make use of these turning forces to provide an advantage. If you look at some of the machines, you can see the turning effect is used. Another example is shown here. Now you can see the pivot or the turning point, and distance is given as 0.5 meters, half meters. The force is 10 Newton. Perpendicular distance from pivot to the force D is 0.5 meters. Force is 10 Newton. Then what is the moment? Moment equals F into D. 10 Newton into 0.5 meters. The answer is moment is 5 Newton meters if you multiply. This is a clockwise moment. This is a clockwise moment. The force will rotate the object in a clockwise direction about the pivot. Another example is shown here. Given here, a force of 50 Newton is applied to a door handle 12 centimeters from the hinge. Now here, you have to keep this in mind. The distance is given in centimeters, 12 centimeters. You have to convert it to meters. Calculate the moment of the force. Perpendicular distance from pivot to the force D, you have to divide by 100 to convert it to meters. 12 centimeters. If you divide by 100, you get 0.12 meters. The turning force is 50 Newton. How do you calculate the moment? F into D. 15 times 0.12, then the answer is 1.8 Newton meters. The moment of the force is 1.8 Newton meters. See, these are easy calculations. Another example is shown here, given here. Now you can see nut key here. A force of 40 Newton is applied to a spanner to turn a nut. Now you can see the spanner. The perpendicular distance is 30 centimeters. Again, they have given here in centimeters. Then you have to convert it to meters. Calculate the moment of the force. Perpendicular distance from pivot to force D equals 30 centimeters. You have to divide it by 100. Then you get 0.30 meters. The turning force is 40 Newton. Then the moment, you have to write this, F moment equals F into D. You must write because you gain marks for these. If you don't write, no marks. Moment equals 40 Newton into 0.3. Then the answer is moment equals 12 Newton meters. It's clockwise moment. Now you can see this arrow, it is clockwise moment. Now another example. I have given you so many examples, then you will be able to answer the questions given in your textbook and in the past papers as well. Right, now you can see a bar again. A bar is balanced on a pivot shown here, and the weight of the left hand side force is 10 Newton and right hand side is 20 Newton. The distance is 1 meter. Now look at this. Clockwise moment equals 20 into 1, 20 Newton meters. Anti-clockwise moment is 10 into D. Now they have asked how far is the 10 Newton weight from the pivot. You have to find the distance D. How do you calculate that? Now look at this step by step. I am going to explain. The beam is balanced, and so from the principle of moments we know that total clockwise moment about the pivot equals to the total anti-clockwise moment about the pivot. Calculate each individual moment first. First we will calculate anti-clockwise moment. F into D. F is 10 Newton, D is not given. So F into D equals 10 Newton into D. 10D Newton meters. This is the unit. That is anti-clockwise moment. Then we will find the clockwise moment. How do you calculate? Clockwise moment. Perpendicular distance from the pivot is 1 meter. Force is 20 Newton. The clockwise moment equals F into D, 20 Newton into 1 meter. That is 20 Newton meters. If the bar is balanced, the total clockwise moment is equal to the total anti-clockwise moment. 10D equals 20 Newton meters. So 20 Newton meters you have to divide by 10, then you get D equals 2 meters. So the 20 Newton weight is hung 2 meters away from the pivot. See how easy these calculations are? Another example is given here. A parent and a child are at opposite sides of a playground seesaw. The parent sits 0.8 meters from the pivot. The child sits 2.4 meters from the pivot and weighs 250 Newton. Calculate the weight of the parent if the seesaw is balanced. If the seesaw is balanced, you have to calculate the weight of the parent. Shall we do the calculations? Look at this. The seesaw is balanced, and so from the principle of moments, we know that total clockwise moment about the pivot is equal to the total anti-clockwise moment about the pivot. Anti-clockwise moment of the child F into D. The distance is 2.4 meters. The force is 250. So you have to multiply 250 Newton into 2.4. The answer is 600 Newton meters. The clockwise moment, the parent's moment. The clockwise moment is the parent's moment, F into D. Perpendicular distance of adult from the pivot is given as 0.8 meters. The force is not given. The clockwise moment, F into D, F into 0.8 meters. We have to find F here. The total clockwise moment is equal to the total anti-clockwise moment. 0.8 into F equals 600 Newton meters. So 600 Newton meters you have to divide by 0.8, then you get 750 Newton. So the parent's weight equals 750 Newton. Now look at these pictures. First picture, moment, we have to find the moment, 50 Newton into 0.8. The force is applied to this direction. So this is we have to mention whether this is anti-clockwise or clockwise. What do you say? Now this is anti-clockwise. This one turns to this direction, anti-clockwise. This is also anti-clockwise. Now see, 50 Newton, you have to take the perpendicular distance, 50 Newton into 0.6, 30 Newton meters. Now here, moment equals 50 Newton, force is given but no perpendicular distance. So the moment is also 0. That means this one doesn't rotate. This one doesn't rotate. Now look at this picture. Another example is given here. There are two weights shown here, 5 Newton, and this one is not given. F, you have to find it then. 5 Newton is given, F is not given. The distances are given from the pivot. Now this right hand side distance is 0.5 meters. Left hand side, the distance, perpendicular distance is 0.25. I think now you all can calculate the clockwise moment and anti-clockwise moment. We'll see. Clockwise moment equals anti-clockwise moment if the bar is balanced. 0.5 into 5 Newton, 0.25 into F. So you do the calculation like this and find F. It's easy for you to do the calculations. Now we are going to discuss what is a couple. 11.2 given in your textbook, the couple of forces. To rotate an object with a single force, that object must be pivoted to a fixed point. It is possible to rotate an object that is not pivoted with the use of two forces acting in opposite directions. So then what is a couple of forces? A couple is a pair of forces having same magnitude but opposite direction and having different line of actions. Now you can see in this picture a pair of forces having same magnitude FF but opposite in direction. One is to this direction, the other one is to this direction, and different line of actions, right? Different line of action, that is called a couple. Definition, I have given you a definition of a couple. A couple is composed of two forces that are equal. Keep that in mind, they are equal. And B, they are anti-parallel. Parallel but in opposite direction. They are parallel but in opposite direction and they do not pass through the same point. This is the definition of a couple. Now I have shown you some examples for couple of forces. Now you can see the steering wheel as I explained earlier. Two similar forces, opposite, steering wheel, and you can see butterfly nuts like this. Butterfly nuts, they are also examples for couple of forces. Tap, you can see the two forces applied on the tap like this. And here you can see two rockets. When they start working, this one applies a force on this and it will move to this direction, and this one, when the air passes out, this will move to this direction. So these two rockets will allow this wheel to rotate. Now here are some examples for couple of forces. Some more examples. Now if you take the key also is also an example for couple of forces, and you can see a driller here. Driller is shown here. It is also an example for the couple of forces. That is the end of my lesson. So thank you for joining again, and please do subscribe to watch more videos, science videos. Thank you for watching. Thank you.